Good morning to all present here. I am Daisak Navas of grade 7 studying in Frontline Newgen International School. Today I came up with an interesting topic which is something related to aerodynamics. Yes, my topic is rocket science. First, what is meant by rocket science? Rocket science is a colloquial term for aerospace and aerodynamics. It is also defined as the science of designing or building rockets. It is called as rocket science as this term was originally used by engineers who worked on creating lots and lots of rockets during the World War II. Now we will see about a rocket. A rocket in its simplest form is a chamber enclosing a gas under a pressure. A small opening at one end allows the gas to escape, which propels the rocket in the opposite direction. Best example for it is a balloon. When you blow a balloon without tying it, if you leave the balloon, the gas has a path to escape. This propels the balloon in the opposite direction. Same like it is a rocket. Now we will see about its principles and characteristics. A rocket works on Newton's third law of motion. It states that for every action there is an equal and opposite reaction. It also states that the objects in rest will stay at rest and the objects in motion will stay on motion unless acted upon by an unbalanced force. It ejects fuel out its back. Now we will see about its characteristic. A rocket can operate in space as well as the surface of the earth. They can be built to deliver very high thrust. Rockets deliver satellites to space where they begin to do their important work. Without rockets, we wouldn't be able to use our cell phones, watch lots and lots of our favorite television shows, find out the weather forecast, or navigate with the global positioning system, which most of you use today, known as GPS. Now we will see about its main parts. There are four main parts of a rocket. They are rocket body, rocket engine, nose cone, and fins. First, we will see about nose cone. The nose cone is the conically shaped forwardmost section of a rocket, guided missiles, or aircraft designed to modulate the oncoming airflow. It has a shape that causes the air to flow smoothly around the rocket. It is typically made from plastic, balsa wood, hardwood, fiberglass, or styrofoam. Now we will see about fins. Fins control direction and stability. The stability of a rocket is its ability to keep flying through the air, pointing in the right direction without wobbling or tumbling. The reason why rockets have fins has to do with stability. These fins are used on smaller flights to provide this stability and control direction. A minimum of 3 fins are recommended for a stable flight. When a rocket is flying through the air, changes in the air can make the rocket wobble. If it wobbles too much, it can go off. Now we will see about the rocket body. The rocket body is not one of the more influential parts. The purpose of this body is to house the fuel. It is often in the form of a hollow cylinder, as this reduces the surface amount area that is in contact with the air. This in turn reduces drag. A rocket must withstand the strong forces during launch and be as light as possible. So, for the main frame, most rockets use aerospace grade aluminum or titanium, since both metals are very strong and lightweight. The rocket propellants and rocket engine are there in this rocket body. Fins are also attached to the rocket body. Now we will see about the rocket engine. The rocket engine are reaction engines providing thrust by ejecting a mass rearward in acceptance with Newton's third law of motion. Non-combusting forms of rockets also there, such as coal gas thrusters and nuclear rockets also exist. There are 4 types of rockets. They are solid propellant rocket, liquid propellant rocket, hybrid propellant rocket, and monopropellant rocket. In this, there are 2 main categories of rocket engines. They are solid rockets and liquid rockets. Now we will see about them. in detail. A solid rocket is a solid propellant rocket or rocket with a rocket engine that uses solid propellants. The earliest rockets were the solid fuel rockets powered by gunpowder. They were used in warfare by the Chinese, Indians, Mongols, and Persians as early as the 13th century. Most rockets use some form of solid or powdered propellants up until the 20th century, when liquid rockets offered more efficient and controllable alternatives. These solid rockets are used as air-to-air and air-to-ground missiles on modern rockets. They are also used as a booster for satellite launches. Now we will see about some of its facts. A solid rocket is a solid propellant rocket. As the name suggests, it uses solid fuels for its combustion. Its speed is 2.1 to 3.2 km per second. The hotness of this engine is 5000 degrees Fahrenheit. Chandrayaan-3 is a solid propellant rocket. Now we will see about its inventors. Robert Hutchings Goddard was the inventor of the first solid rocket. He was born on Worcester, Massachusetts, Goddard. He graduated from the Worcester Polytechnic Institute in 1908. Now we will see about Vikram Sarabhai. Dr. Vikram Sarabhai was an Indian physicist and astronomer who initiated space research and helped to develop nuclear power in India. And also, he is the founder of the first solid rocket in India. He was honored with Padma Bhushan in 1966 and Padma Vibhushan in 1972. He launched Vikram 1 with 3 solid fuel powered stages. Now we will see about its working. A solid rocket has its fuel and oxygen mixed together as fine powders and then pressed into a solid cake. Once it has been lit, it will carry on burning until it is used up. In a black powder rocket, the fuel is carbon and the oxidant is potassium nitrate. Now we will see about its advantages and disadvantages. A solid rocket is much easier to store and handle than liquid rockets. They also provide a large amount of thrust with a relatively simple design. Now we will see about its disadvantages. The disadvantages of a rocket is that the motor of a solid rocket cannot be controlled once ignited. The specific impulse is rather low because of the low chemical reactivity caused by the low chemical energy. Now we will see about liquid rockets. Liquid rockets or liquid propellant rockets are rocket with a rocket engine that uses liquid propellants. They can also be monopropellant rockets using a simple type of propellant. Gaseous propellants may also be used, but they have a difficulty with common pumping methods and have a low density. Liquids are desirable because they have a reasonably high density and high specific impulse. This allows the volume of the propellant tanks to be relatively low. The liquid propellants are usually pushed into the combustion chamber using a lightweight centrifugal turbo pump. Now we will see about some of its facts. A liquid rocket is a liquid propellant rocket. So, as for this too, the name suggests it uses liquid fuels for its combustion. Its speed is 5000 meters per second or 5 kilometers per second. Yes, it is faster than the solid rockets. Now we will see about its inventors. Robert H. Goddard was the inventor of the first liquid rocket. Yes, he is the same person who invented the first solid rocket too. He is considered as the father of modern rocket propulsion. He launched it on March 16, 1926. Now we will see about a famous person who is Nambi Narayanan. Nambi Narayanan played a crucial role in inventing the first liquid rocket in India. Nambi Narayanan was an Indian aerospace scientist who worked for the Indian Space Research Organization, ISRO. He was born on 12th December at Nagarkoil, which is present-day Kanyakumari in Tamil Nadu. He studied aerospace engineering in Madurai. After completing aerospace engineering in Madurai, Narayanan started his career in 1966 at ISRO as a technical assistant at the Tumba Equatorial rocket launching station. He was sent to Princeton University on deputation of Government of India's expenses in 1969. He completed his master program there on chemical rocket propulsion under Professor Luigi Crocco. He returned to India with expertise in liquid rocket propulsion at a time when Indian rocketry was still solely dependent on solid rockets. Narayanan had claimed that he had to educate Sarabhai on liquid propulsion technology in his own book. As a senior officer of ISRO, Narayanan was briefly in charge of the cryogenics division. Cryogenics means the production of behavior of materials at very low temperatures. On 30th November 1994, Narayanan was arrested as a part of an investigation of alleged espionage by a team of Kerala police and intellectual bureau officials based on the videograph statement by a colleague that he and Narayanan had received money for transferring the drawings and documents of rocket engines to two Maldivian women, Mariam Rashida and Fauzia Hassan, who were suspected to be spies. Narayanan spent 50 days in jail. He claims that the officials of the intellectual bureau who initially interrogated him wanted him to make false accusations against the top brass of ISRO. He also claimed that two IB officers had asked him to implicate A.E. Muthanayagam, his boss and then director of the Liquid Propulsion System Center LPSC. When he refused to comply, he was tortured until he collapsed and was hospitalized. After lots and lots of obstacles like these, Narayanan finally founded the Vikas engine. Now we will see about the working of a liquid rocket. The stored fuel and stored oxidizer in a liquid rocket are pushed into the combustion chamber where they are mixed and burnt. This combustion produces great amounts of exhaust gas which is rich in temperature and pressure. This exhaust gas is passed through a nozzle which accelerates the flow. Now we will see about its disadvantages and advantages. Although these liquid rockets have many advantages, based on these advantages, there are disadvantages for the liquid rockets too. First, we will see about disadvantages. A liquid rocket enables high tankage efficiency. They can also enable a very high specific impulse. Now we will see about its disadvantages. The disadvantages of a liquid rocket are it adds the extra need for pumps and piping. They also need a separate storage for their fuel and oxidant. I hope you all found my lecture interesting. Thank you.